Okay, for this video, we're going to jump to section 2.5, and basically what we're going to do are absolute value equations. This is the last section where we're going to solve for equations, and we're going to apply when we have absolute value bars around x. Before we get to those equations and expressions with absolute value bars, let's first look at a real-life example, which really kind of gives us kind of a good intro of the whole meaning and purpose and where we can apply absolute value. Okay, if we look at this, we read through it, we have the temperature of an enclosure for a pet snake. Okay, so where a pet snake, where it should be, where its habitat should be about 80 degrees Fahrenheit, give or take 5 degrees. Find the maximum and minimum temperatures. Okay, this is kind of the key parts here, 80 degrees Fahrenheit and give or take 5 degrees. That's very important right here. So if we look, if it says give or take 5 degrees, that's just like absolute value. Remember, absolute value, the definition was the distance from 0 to a number on the number line. And you can go either way. You could go to the right or you could go to the left. Well, that's the same thing here. Instead of using 0, we could use 80. Love my straight lines there, huh? Okay, here we go. Not too bad. All right, so we'll say this is 80 degrees. So it's saying give or take 5 degrees. That means I could go this way 5 degrees, which would be 85. Or I could go to the left 5 degrees of 80, so that's 75. So that's my max and my min. So I'll write min is 75, and the max is 85. So there's a good example right there. You could go to the right or you could go to the left. So when we solve for equations, we have absolute value. We could go to the right or we could go to the left. And you'll see once we solve it. Okay, let's look at some problems where we evaluate. So these are not equations 1 and 2. Okay, for number 1, we have this expression, the absolute value of m plus 6, and then it has minus 14. Now it says if m equals 4, so what we're going to do there, we're going to plug 4 in for m. It's the very first thing we do. So we plug 4 in for m, we have 4 plus 6, and then we have minus 14. Now remember we did order of operations, you always do grouping symbols or parentheses first. Well, on absolute value bar, this is a grouping symbol, so we do that first. So 4 plus 6, well that's 10, and the absolute value of 10 is 10. So we just get 10 out of that. Then we just do 10 minus 14, simple subtraction problem, that gives us negative 4. So that's our answer. Okay, number 2 is going to be a little bit more complex. I don't have a whole lot of space here, so I'm going to erase what I just did for number 1 and use the whole space underneath 1 and 2 for number 2. So here we go. Let's get rid of this. Okay. All right, so we have values to plug in for x. X is negative 2, y is 4, and z is negative 3. So let's plug this in. So for 2, we're going to have 3 times the absolute value of x, which is negative 2. Then we have minus the absolute value of negative 2, because that's x, minus y, and y in this case is 4. And then we have plus 2 times z, z is negative 3. Okay, as we did before, let's evaluate what's inside the absolute value bars. Okay, this absolute value of negative 2, well that is 2, so that becomes 3 times 2. Let's see here, negative 2 minus 4, well this is the absolute value of negative 6. Notice how I still keep it in absolute value bars. Then the absolute value of negative 6 is 6. Notice how I don't make each of these, and you might say, well, you get the same answer anyway. Don't make this positive 2 and plus 4, and it actually turns out you get the same thing, 6, but don't get in that habit. Evaluate what's in here first. In other words, don't change the negatives to positives. At the end, once you get this number, then you change this sign, which is positive 6. Okay, and then I can multiply these. Well, 2 times negative 3 is negative 6. Okay, and then let's see here. I'm going to erase some of this. I told you kind of was squeezing this in, so I'll get rid of this right here. All right. So then if I do this, well, this 3 times 2, that's another 6, which I'll put there. Then I'll put the rest over here. Then it's minus 6, and then plus a negative 6. So let's see here. 6 minus 6, that would be 0. So then I would just end up with this as my answer, -6. All right, so that took a little bit more work there, but you evaluate what's inside the absolute value first, then you take the absolute value of it, and then you just follow order of operations. All right, now getting to the whole goal, and the main concept here are absolute value equations. We're going to look at 3 different cases. We can break down absolute value equations into 3 basic cases. Most cases are this right here. Okay, this is saying absolute value of x equals 4. Now we can get, if I look at a real number line, I have 0. So basically it's asking you, all right, where can you go on the real number line that's 4 units from 0? Well, I could go to the right 4, that's 4 units from 0. Or I could go the other way. This is just like the real life example with the 80 degrees. I could go to the left 4, so I have 2 solutions. Each of these are 4 units from 0. So my 2 solutions are x equals 4 and -4. Most cases that you get when you solve an absolute value equation, you're going to get 2 solutions. Now, there's other 2 cases where we don't. The next example, well, if you have absolute value of x equals 0, you're already here, right? See where I'm putting the point here on 0? So you don't have to move anywhere. You only get 1 solution. It's just x equals 0. That's it. You can't take plus or minus 0. Plus or minus 0 is just 0. Okay, the third case is where I have it set equal to a negative. Now remember, absolute value is distance. You never ever say that you traveled a negative distance. So you can never ever take the absolute value of a number and get a negative. In this case, it's -2. So if you ever see this, your answer is no solution. As I said, most cases, you're going to get 2 answers. All right, let's apply this to the next 3, 3, 4, and 5. Okay, this one we have a lot of space here. This is good. All right, now I'm going to look up right here. See how here I basically took this absolute value of x and I set it equal to the positive and negative of this number 4. I'm going to do the same thing, but it's going to be 17. So I'm going to set that quantity, x plus 5. One equation is just going to be x plus 5 equals 17. The other equation I'm going to write down here, that x plus 5, it could also equal -17. Because if it equals -17, then when I take the absolute value of it at the end, it equals 17. Now I just have one-step equations. I subtract 5, subtract 5. So I get 17 minus 5, that gives me 12. So there's an answer. Here I subtract 5. -17 minus 5 is going to give me a negative. Since they're both negatives, I add the numbers. 17 and 5 is 22, but it's going to be -22. So these are my 2 answers. Okay, for number 4, when I move on to that, I'm going to just switch it around and write the y plus 2. I can say that's equal to 4, or I could say it's equal to -4. But I keep that expression inside the absolute value the same. Then I just do the one step. I just subtract 2, subtract 2. So 4 minus 2 gives me 2. That's a solution. I do the same thing for the second equation. I subtract 2, subtract 2. -4 minus 2 gives me -6. There's a solution. Okay? And the last one on here, number 5, I see right away I have this absolute value by itself and it's equal to a negative. So this is just like this example right here. This in a different color. It's just like this example. All right, it's equal to a -2, so it's no solution. So for 5, I don't have to do any work, no thinking involved. Can never take the absolute value of a number, get a negative, so I get no solution. Okay, you can see on the sheet I have 6 and 7. I'm not sure if I'll do that in class. It's not filled out for you. We're not going to do it here, but this covers everything. Gives you a good real-life example of applying absolute value. We evaluated some, but what was most important were 3, 4, and 5. Most cases you get 2 solutions. This case, where it's set equal to 0, you get 1 solution. If it's set equal to a negative, like here, you get no solution. So that is it. That is 2.5 absolute value equations.